So I'm going to go ahead and provide a complete analysis of this function s of t, just like we did in class, just like the problem that you guys competed on. And the first thing we want to do is find v of t, but actually before that, let's just make sure we understand what we're looking at here. S of t represents the position of a moving object, and I'm just going to call it right and left. I don't remember what it says on the worksheet, but let's say we have an object traveling right and left along, let's say, the x-axis, and the position at time t is represented by s of t. Okay, and so we could easily, really quickly, figure out what the position of this moving object would be at the beginning, meaning when t is equal to 0. And s of 0 we can see is all the terms go to 0 except the last term, so s of 0 is negative 11. So if we take a look, we can draw a number line here, and let's say we put 0 right there, and negative 11 is where this object is at time t is equal to 0. So that's where we're going to start. Okay, and so let's go ahead and take the derivative of s of t. Now the derivative of s of t, we know that to be the velocity. Okay, so the velocity is 3t squared minus 18t plus 24, and let's go ahead and find the acceleration as well. Acceleration is the second derivative of the position, or the derivative of the velocity. Okay, so the acceleration would be 6t minus 18. Okay, so 6t minus 18. Now we want to know when this particle is moving to the right and when it's moving to the left. We know that when the velocity is positive, the particle is moving to the right. And so let's take that velocity. Hold on a second, my dogs are going nuts. Close the door. Alright, time back in. For us to know when the velocity is positive and negative, we first want to figure out where the velocity is 0. So velocity equals 0 when this function, the velocity function, 3t squared minus 18t plus 24 is equal to 0. So we can divide every term by 3, get rid of that extra factor that we don't need. And when we divide the first term by 3, we get t squared. Dividing the second term by 3, we get negative 6t. And then dividing the third term by 3, we get 8. Okay, is equal to 0. So that's a much easier function to go ahead and factor. So we can see the left side factor is t minus 4 times t minus 2 is equal to 0. So it's nice, we have nice round numbers to deal with. And if you remember, at the end of pre-calc honors, we did sign charts to determine when a function was increasing and decreasing. This is the same thing. Also, if we want to know when this left side is equal to 0, well, easily we have that. I don't want to t equals 4 and t equals 2. Those are the two times when when v is equal to 0. Okay, I just had to pause. Had somebody come in the room. Anyway, I don't remember exactly what I was just saying, but here we have the two values of t, which are the two times t equals 2 and t equals 4 when the velocity is equal to 0. And way back when we did sign charts to determine when we were finding domain at the beginning of pre-calc honors, and at the end of pre-calc honors we were finding when is f increasing and decreasing. Well, we always have to make sure we can use a sign chart to determine the sign of the in this case of the left side. We want to know when the velocity is positive and when it's negative. Okay, so we're going to pick values of t in between these intervals, or on these intervals, from 0 to 2, 2 to 4, and 4 to infinity. And from 0 to 2, we want to figure out what the velocity is. Okay, so the velocity is, let's pick a test value of 1. Okay, and the velocity at 1, let's see, if we plug 1 in to the two factors here, we get 1 minus 4, and that's a negative. 1 minus 2 is also a negative, so we have a negative times a negative. So on this interval here, we have that the velocity is actually positive. So from 0 to 2, the velocity is positive. Let's just confirm that. Okay, so when t equals 1, we have 3 minus 18, that's negative 15 plus 24. So yes, velocity is positive on that interval. Okay, and then from 2 to 4, let's pick a test value of 3 and the velocity at 3. Okay, so if we plug in t equals 3, we get 3 minus 4, which is a negative, 3 minus 2, which is a positive, and so we see a negative times a positive, and we get negative. So the velocity is negative between 2 and 4 times t equals 2 and t equals 4. And then when t is greater than 4, we see, let's say, a test value of 10. When t equals 10, 10 minus 4, 10 minus 2. So I'm plugging these t values into this left side here, these factors, because these factors will determine our sign of our velocity. Okay, so when t equals 10, we have positive times a positive, and therefore we know that the velocity is positive for all values of t greater than 4. So we can do a quick analysis here that tells us that the particle is actually moving to the right from t equals 0 to t equals 2, then moving to the left from 2 to 4, and then moving back to the right forever after t equals 4. Okay, so we know the right and left hand motion of this particular object, and then we have to figure out when is it speeding up and slowing down. And so I'm going to go ahead and erase a couple of these things here so that I have some room to work with. I'm going to erase all of this stuff here. Okay, so hopefully you've got that down. Rewind the tape if I erased something that you didn't write down and you want to write it down. Okay, so we can also erase that part, but I want to keep my chart here so that I can refer to it while I'm figuring out if the particle's speeding up or slowing down. So we want to look though at the acceleration, because remember, when the acceleration and velocity are working together, this particle is speeding up. Okay, so we want to know when the acceleration is 0. So the acceleration a of t is 0 when that 6t minus 18 is equal to 0. In other words, adding 18 to both sides, and then, I just had more room. Add 18 to both sides, and then divide both sides by 6, gives us that t is equal to 3. Okay, so at the t equal 3 value, we see that the acceleration is equal to 0. And let's build another sign chart here. And it would be nicer if we can build it underneath. So I'm going to go ahead and do that. I'm going to build that sign chart for the acceleration underneath the sign chart for the velocity. And I think it'll be a little easier to see what is going on. So the blue sign chart is the velocity, and the green sign chart then will be our acceleration. Remember, t starts at 0, so we're good there as far as we don't need to worry about what's going on left of 0. Doesn't make sense in our problem. Okay, so then we just want to figure out the sign of acceleration in between 0 and 3, and then anywhere bigger than 3. So from t equals 0 to t equals 3, let's pick another test value. Let's pick 1 again. And when t equals 1, we see that the acceleration at 1 is equal to 6 minus 18, which is negative. Okay, so the acceleration at 1 is negative, meaning the acceleration is going to be negative for the entire interval from t equals 0 to t equals 3. Okay, and then let's pick another test value. Let's pick 10 again. The acceleration at 10 would be 6 times 10, or 60, minus 18, obviously positive. And so that was a 10 there. So therefore, from t equals 3 to infinity, so when t is greater than 3, we see that the acceleration is positive. Okay, so now what we want to do is analyze when is the particle speeding up and when is the particle slowing down. Okay, so I'm going to go ahead and erase this stuff that I have in the lower right hand part of my screen so we have plenty of room to work with, and we can write down our complete analysis here. Okay, so one thing I want to do here is I want to draw a line right through the 3's. Okay, and then I'm also going to draw a line, let's see here, Yeah, okay, so I want to draw a line here where we have a sign change for the velocity. So basically I'm drawing a vertical line through these two sign charts where we have either a sign change for the velocity or a sign change for the acceleration. Okay, so we can see that on the interval from 0 to 2, let's just write this down here. On the interval from 0 to 2, we see that the velocity is positive, but the acceleration is negative. Okay, and then we can see that on the interval from 2 to 3, that's another interval, we can see that the velocity is negative, and the acceleration is also negative. Okay, and on the interval from t equals 3 to t equals 4, we can see that the velocity is negative and the acceleration is positive. And then from 4 to infinity, we can see that both the velocity and the acceleration are positive. Okay, so there's our sign chart analysis, but now we just need to interpret what that means. Okay, and kind of ran out of room here to write down what that means. So what should I do here? I'm going to go ahead and I'm going to erase my sign chart. Hopefully you guys don't mind that. Oops, I'm going to get my eraser first. So I'm going to erase the sign chart. I'm at 11 minutes 40 seconds. And then I'm going to say, alright, to the left of this, from 0 to 2, we have velocity and acceleration working against each other. So we say that the particle is slowing down. I should write that better. Let me do this a little bit nicer. So we say that, again, the particle is slowing down on the interval from 0 to 2. Okay? It's also slowing down. Well, let's just work one at a time. Notice from 2 to 3, t equals 2 to t equals 3, the particle is speeding up. It's moving left, and acceleration pushing left. So we have speeding up, and where is that? There. So again, we have that the particle is speeding up on the interval from 2 to 3, and then we see, again, from 3 to 4, velocity and acceleration are working against each other, so we are slowing down there, slowing down on that interval, and then the particle is moving right and pushing right from t equals 4 to t equals infinity, so therefore the particle is speeding up on that interval. And that's most of the analysis, but it would be kind of nice if we took a look at to see what exactly and where this particle is at certain times. And so I'm going to get my calculator out, and so I don't have to fumble around with the math on this. So hold on one second. Okay, and just to clear a little bit more space, I'm going to be showing a little bit of work here in the middle. Okay, we already know where the particle is at t equals 0, but if I want to find out where the particle is at certain times, I just need to plug those certain times back into the position function. And so what I want to find out is where's the particle at t equals 2, and the particle at t equals 2 is s of 2, and s of 2, if you replace t in the s equation with 2, you get 9. And then I want to know where the particle is at t equals 3. When you replace t with 3 in the original equation, you get 7. And then we say s of 4, I want to know where it is at 4, and the particle at 4 is at, when t equals 4, has a position of 5. Okay, so let's take a look now, and let me make my number line here a little bit nicer for us to work with. So I'm going to extend that, and I know now that I have to go all the way to 9. So let's put a 0 right there, and let's put 9 right there, and then 7, and then 5. So those are our key positions at certain times. So at t equals 0, remember, the particle is moving to the right. Velocity is positive from 0 to 2. So we have this particle moving to the right, but slowing down, getting all the way to 9. Okay, so the particle is right there at 9. at the time t equals 2. Okay, t equals 2 is right there. T equals 2 right in that spot. Okay, then the particle is going to move backward, and I'll choose a different color for that. Since the particle is speeding up then from 2 to 3, but velocity is negative, as you notice down here, so you can get everything you need from this spot right here. Velocity is negative, that means the particle is going to move back to the left, and then but speeding up from 2 to 3. Okay, and so at the 3-second mark, it's going to end up at 7. Okay, so there's a lot to do here in this little spot. So you're going to go from here to here, from t equals, did I mess up? What did I do? Velocity, oh, 3 to 4. Oh yeah, okay, we're good. So from 3 to 4, yeah. Alright, sorry, just want to make sure I got it here. Oh man, my video, it's going past 15 minutes. What am I going to do? I don't know. I guess I better stop and pick this up in the next video.